We're asked to find the lengths of the sides of the triangle. So there's something called the distance formula you could use for this, but I prefer to give students as little formulas as possible. Let's go back to geometry. The one that we keep hearing over and over in geometry class is the Pythagorean theorem, right? Look, I just drew a right triangle here. This goes from 0, 0 to 3, comma 3, this line right here. So that means this has a distance of 3. And from 0 on the y to 3 on the y, this has a distance of 3. We can find out our goal for this black line by using a squared plus b squared equals c squared. If you look up the distance formula online, you'll see it's just this, the Pythagorean theorem, just rewritten. 3 squared is 9, so 9 plus 9 makes 18. And then to get c by itself, you need to square root of both sides. And later on in the course, I think we're going to practice how to simplify this radical. But right now, you can just put it in as square root of 18. Okay, if you think you're better than me, go ahead and figure out what that radical is simplified. But now we need to find this. That line might be a little bit trickier. Let's see, how are we going to make that into a right triangle? Ba 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 ba. Do 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 do. I'm trying to make it into a right triangle. I don't think there's any way of easily visualizing the right triangle. I think here we need the distance formula. Let me see. Is that in our textbook? Yeah, it's on page 16 of our textbook. I'm sure there's a way I could draw this with a right triangle. I just can't picture it. So this blue line here, we need to know that distance. So the distance formula is just a rearrangement of the Pythagorean theorem. It's the difference in the x-coordinates, so x1 subtracted by x2 squared, plus the difference in the y-coordinates. And look, it doesn't matter which one comes first, x1 or x2, right? Because if you swap their order, you're just changing it from positive to negative, assuming it's not 0. And then if you square a negative, it makes it positive. So you can't get the order wrong as long as you... No, never mind, you can't get anything wrong there as long as you plug the numbers in where they're supposed to go. So the distance formula works like this. Plug in these x-coordinates. So I'm going to do 3 minus negative 4. That's being squared. And then plug in the y-coordinates. 3 and positive 4. So 3 minus 4 squared. And so 3 minus a negative 4, make sure the subtraction sign is built into it, so you're subtracting a negative 4. So that makes 7. 7 squared is 49. And 3 minus 4 is negative 1. Negative 1 times itself is 1. And so that gives us square root of 50. Okay? Again, if you're better than me, go ahead and simplify that radical if you know what I mean. And if you don't know what I mean, that's okay. We're going to do that later. And then here to here. You could use the distance formula, or you could use the right triangle. The right triangle is easy to draw here because from here to here, that's 4 units on the x-axis. Never mind that it's negative. It's a distance of 4. And then from here on the y-axis to here, that's positive 4. So a squared plus b squared equals c squared. So what are we going to get? Square root of 32, I think. So the lengths are adding up all these three. And you could just say square root of 32 plus square root of 50 plus square root of 18 for your answer. And show that the triangle is a right triangle. It's a right triangle if it obeys this formula, the Pythagorean theorem. And the hypotenuse always has to be the biggest in the Pythagorean theorem. So if you're going to plug those in, you're going to plug in the square root of 32 here. You're going to plug in the square root of 18 here, or vice versa. Those two can be swapped, but they can't be swapped over here. Square root of 50 has to be the c, because that's the biggest side. And if you simplify that, squaring a square root gets rid of it. And that's a true statement, right? 32 plus 18 makes 50. So since the side lengths hold for the Pythagorean theorem formula, this has to be a right triangle because the Pythagorean theorem says that this is a right triangle if the side lengths equal each other when they're squared and added.